Alright, so in this video, we're going to be talking a little bit more about cotangent. But we're now getting to that phase in which we're going to be talking about the reciprocals. Right? So, if you know how to graph sine, cosine, and tangent, graphing the reciprocal, secant, cosecant, and cotangent will become easier. So I just want to give you guys a little table before we actually get to this graphing part that you need to copy down. So if we have sine is equal to 1 over cosec, or cosecant. Cosine is equal to 1 over sec, which is secant. And then tangent, or tan, is equal to 1 over cot. So I want you guys to copy down this table. It's going to be very helpful for our future videos to come. Alright, so now let's actually get to this graphing part. What I want you guys to understand is that the reciprocals, they have no amplitude because they go infinitely up and infinitely down. So the amplitude, you always write none on your exam, and you guys are going to see when we get to those real images that doesn't really matter, right? So let's say we have y equals cot x over 3. A lot of students get confused when they see this, and that's why I'm trying to make it clear for you guys now. So your amplitude, you don't care. So you straight go to your period. You go straight to your period. In this case, as I said, for tangent and cotangent, your period is always, but always going to be pi divided by your b. It's not 2 pi divided by your b. It's just pi divided by your b. So what's our b in this case? That's the tricky part. So what does this represent? Right? If you get into the algebraic part, you know, let's just make this pi a little bit better, first of all. So when you guys know that when we're dealing with this, you can say that this is cot of, this is how you can write this. This is a simpler way to write this. But you guys have to know how to do this because when we get to the technology part, I'm probably going to name it like this if I ever need to. So that's important. It's important to know that we're going to be dealing with this right here and this. So if we're going to translate this, our period is just going to be equal to pi divided by 1/3, and we're dividing a number by a fraction, we multiply by the reciprocal. So it's the same thing as doing pi multiplied now by 3 over 1, which equals 3 pi. So this is where our period, this is the length of our period right here. And now the next thing we go at is our x scale. And remember our x scale now, the good thing now about the x scale is that we have it. We only have 2 major points. Remember, the asymptote, the intercept. Right? We only have these 2 major scales to have it by. Right? So this is why, this is our period, first of all. And our x scale is going to equal to 3 pi half. We can't simplify this. And now, we have our x scale, we have our period, we have our function, right, our cotangent. So what we need to do now is we have to do what we call phase shift. But remember, we take what's inside our function and we equal it to 2 endpoints. And what changes, and what this changes into is to tangent, is that if we want to choose our x, like our start and our end, in terms of endpoints for our intercepts or endpoints for our asymptotes, I would always recommend you guys always choose your endpoints as your asymptotes. So for that, we can do x over 3 equals, and what you need to remember now, you have to remember what your 2 endpoints for your asymptotes will be or will become, and these are 0 and pi. So this would be your end, and this would be your start. I mean, you don't really have to have your endpoint, right? Because you can use your x scale. So let's just do the start. But if you want to know, or if your exam asks you, you don't have to graph everything. You can just simply use this formula. So let's say x, or 1/3 x, is equal to 0. right? We know there's not going to be no shift because we're going to divide this on both sides, and everything divided or multiplied by 0 will become 0. So we have no phase shift. No. We have no phase shift. So, now let's actually graph this. We have our important points, and what you guys need to remember is the parent graph for cotangent, right? So, I don't think we're going to the negative direction, but you could always go to that negative direction. Actually, we might go, I don't think, well, whatever. So, we're going to be graphing what we have. So, our starting point will be 0. Remember, this is an asymptote. It's going to be our asymptote. And then our next point, what is our x scale? We saw that our x scale right here was 3 pi halves. This is going to be 3. But this is too big. Sorry, guys. So this is 3 pi halves. And if you add, you can either add a period and you'll have your next asymptote. This is the good thing, or this is the greatness of having a period. But let's just go with the x scale. And then if you add 3 pi halves plus 3 pi halves, you have 6 pi halves, in which you can simplify this. But I'm not going to simplify it because it's going to confuse. So if you add more 3 pi halves, you can try to see the pattern here. You have 9 pi halves, and you can keep on infinitely adding more. And we have 9, 10, 11, 12. That's going to be 12 pi halves. And once again, you could always simplify this, and you can keep on adding 3, adding 3, adding 3. But let's just do a period here. So what you have to know is that this right here is just going to be your asymptote, right? This is your start. This is your intercept. So this is your asymptote. Remember, no amp. This is your asymptote. No, this is your period, sorry. No, your x-intercept, sorry. Your x-in, and this is your asymptote. Let's just, no, have that circle there because I'm going to confuse y'all. Right, so, now, if you guys look here. Alright, so, remember, so let's spot the difference here. So let's say we have, well, we have tan, and then we have x here. You can see, remember the graph looked like we have that turning point right there. We have that mini half parabola in this way, the other mini half parabola opening that way. So for cotangent, if we go to functions, right, and we go to cot, and we put x, parentheses, it's like the, sort of like the reflection over the x-axis of this graph. You can see you have your turning point, but this time you have your half parabola opening to the left, and that other opening to the right, right? You have, this is, you can think of it, this is your asymptote, opening there and opening there. So it's sort of like the reflection of your tangent, right? So that's what I want you guys to understand. So if you guys can take a little photo of this, it would be good. But now, let's actually graph this here. Just move some things around. Okay, so remember, half parabola, approaching your asymptote, Remember, these goes infinitely up, So we have that opening there, we have this opening here, and then we'll have, for example, this there, here, turning point is your x in, and you have that curve there. So this is how it would look like. This would be 3 periods, right? This is a period, a period. So this is 3p, right? So make sure you guys know how to do this. Next video, we're gonna be doing cosecant and secant.